Welcome to this presentation on designing SQL Server Availability Groups topology without losing your sanity. Yes, I did include that last line in the title because ever since SQL Server Availability Groups were introduced, database administrators and systems engineers have become so confused as to the different combinations of how to properly design an availability groups topology. And I'll be focusing on design for this presentation, so you won't be seeing demos. My name is Edwin Sarmiento, and I specialize in SQL Server high availability and disaster recovery. I'm a Microsoft Data Platform MVP and a Microsoft Certified Master for SQL Server. You can connect with me on my blog, through email, on Twitter, and even on LinkedIn. Now, I wanted to start with using this illustration. You can find a video on YouTube about the Tacoma Narrows Bridge in Washington in the United States collapsing back in the 1940s. I've learned about this when I was still back in university, when I was taking a course on mechanical vibrations. What happened was that the natural frequency of the bridge coincided with the natural frequency of the wind blowing to a point that their natural frequencies added up and caused the bridge to collapse. The thing about availability groups, and whether it's a technical design or anything for that matter, implementation should start from design. And we fall into this trap. Database administrators and system engineers alike fall into the trap of going directly to the technical aspects without really understanding the business requirements. I've actually recorded a YouTube video that highlights the non-technical aspects of designing high availability and disaster recovery solutions. Now, because availability groups can be used as both high availability and disaster recovery solution, it's important to go back into the business requirement and understand, do we want to build this just as a high availability solution? Do we want this to also include disaster recovery? And I certainly don't want you to fall into the trap of building a high availability solution without a corresponding disaster recovery solution. Now, when availability groups was introduced back in SQL Server 2012, I almost got into trouble with the folks at Microsoft Marketing, mainly because I started telling customers, look, this is really not a new technology. What I mean by that is that if you understand how these two technologies work, you already have an understanding of how it works somehow to give you enough skills to start designing, implementing, and managing an always-on availability group topology. To illustrate, let's start off with the underlying platform, Windows Server Failover Clustering. Availability groups rely so much on this underlying platform. That's why it's important for us to know and understand how it works. And I kind of use the traffic light analogy for this. If you're driving and if you've seen a traffic light, you know that the red light means stop. Yeah, the yellow light means slow down. Again, depending on where you come from, it might mean go faster. And the green light means go. Let's use this traffic light to describe every phases in how a failover cluster works. Let's say a workload is running and suddenly the node that is running that workload goes down. The service will enter a stop phase. The service gets stopped on that node. And then the waiting phase happens. This is the part where the failover cluster will then search the available nodes within the cluster who would be capable of hosting the workload that was just stopped. And then the start service, the cluster will start the particular service on that available node. Let's illustrate this analogy by looking at a traditional two-node SQL Server failover clustered instance. And I'm using this example because, well, failover cluster has been there ever since Windows NT 4. And SQL Server failover clustered instances have been available since SQL Server 6.5. Let's use the stop, wait, and start service to illustrate how failover clustering works. Imagine that the SQL Server service is running on that node, the node on the left. The node on the right is just waiting there as a standby. Let's say you have a client application connecting to your database, and then suddenly the node on the left becomes unavailable. Maybe a blue screen occurred or a power failure occurred. When that happens, the stop service occurs. The SQL Server service becomes unavailable, hence the client application got disconnected. The waiting phase occurs when the cluster starts to look for any of the available nodes that could take over the service that was recently stopped. In this case, the node on the right is available, and so the cluster will then move the SQL Server service to the node on the right. Bringing up the SQL Server service initiates the start service phase. At this point, the client application can then reconnect back into the databases. Now, when you're dealing with failover clustered instances, of course, you're using shared storage. In an availability group, you don't really need shared storage, but the underlying concepts work because it still runs on top of a Windows Server failover cluster. Now, what is not commonly mentioned when you're reading through some of the blog posts or YouTube videos or some of the training materials out there when it comes to availability groups is the dependency on an external object, Active Directory and DNS. This means the availability of your failover cluster depends on Active Directory and DNS. Now let's repeat the whole process again. Let's say the node on the left goes offline. Client application gets disconnected. The cluster actually checks Active Directory for both Active Directory computer object and the DNS entry for the listener name before it could decide to bring the SQL Server service online on the node on the right. This dependency impacts how long it will take for the SQL Server service to be brought online on the node on the right. Why do we even care? Most of the SQL Server DBAs are focused on just the SQL Server database within a particular server. Now that we're dealing with availability groups, we need to depend on Active Directory and DNS on top of the failover cluster. An understanding of these dependencies can spell the difference between a long outage or a quick failover. One of the reasons why you have to be really nice to your Active Directory and DNS guys. Now let's look at the basic architecture for availability groups. We'll look at the underlying platform that availability groups depend on, which is the Windows Server failover cluster. Let's look at how availability groups work. In order for me to build an availability group using these three instances, I need to have all three of the servers be within a Windows Server failover cluster. Let's look at how availability groups work under the covers. We've already covered the failover clustering piece. Let's look at the availability group piece. When a client application sends a transaction to the primary replica, the primary replica will then write those transaction log records on the LDF file. Alongside with that, the primary replica will then send the transaction log records to the secondary replica, And the secondary replica has to write those transaction log records on its own LDF file. When that's done, the secondary replica will have to then tell the primary replica, hey, I've already written my transaction log records on disk. You can go ahead and tell the client application we're all good. Now, this is what happens when you configure synchronous replication between your replicas. If you configure asynchronous replication between your replica, the client application does not have to wait until the secondary replica persists those transaction log records on disk. It will just consider them as committed transactions. Now, between synchronous and asynchronous replication, it spells the difference between losing data and not losing data. Again, going back to what the business requires. You have to have an agreement with the business about the maximum allowable data loss that the business can tolerate. Thus, the choice between using either synchronous or asynchronous replicas. Under the covers, the secondary replicas are always running the redo process. This is replaying the transaction log records on the secondary replicas. Now let's talk about quorum. Now you might be wondering, well, isn't quorum part of the failover cluster? Yes, it is. In fact, it is the most confusing, most complicated, and the most complex concept in the Windows failover cluster. Yet it is the most important one that database administrators and systems engineers are often getting confused with. Quorum determines the number of failures that the cluster can sustain while still remaining online. In my own words, I kind of look at the quorum as majority vote wins. If the cluster can get majority of votes among all the members, it will stay online. If not, well, it will go offline together with the other workloads running on top of the failover cluster. Now, by default, all nodes will have a vote, unless, of course, you remove the vote from a node explicitly. This is how the quorum works. You need to get majority of votes from all of the voting members. And what impacts this is the type of quorum that you configured for your failover cluster. You can have node majority. If you have an odd number of nodes, you can use node majority. Of course, you need 2 out of 3 if you have 3 nodes, 3 out of 5 if you have 5 nodes to achieve majority. You also have node and disk majority, or what is known as a disk witness, where you are using a shared disk as a type of witness for the quorum. A more common one that was introduced in Windows Server 2008 and more applicable to availability group topologies is the file share witness, where you are using a file share as a witness instead of a shared disk. Fourth one, which is no majority, is another option. I really don't see a point of implementing this type of witness, but I'm just including it as part of the list. Totally not recommended, but it's still there as a reference. Introduced in Windows Server 2016 is the concept of a cloud witness, where you are using a file share as a witness type, but instead of hosting it on another server within your internal network, you're hosting it on an Azure blob storage. The goal is to have majority of votes within your failover cluster. Because again, if you fall below the number of votes required to achieve majority, the cluster goes offline and it takes all of the workload offline with it. How do you choose the appropriate quorum model in this case? Well, let your requirements guide your choice. When you're using a failover clustered instance as a replica and you already have a shared storage subsystem, you might as well make the most out of it. But I certainly don't want to be using a disk witness if all I'm simply using are standalone instances. It doesn't make any sense. I'd rather use a file share witness for it. Where do you place the quorum is another question that is commonly asked. This is very relevant, especially if you're dealing with multi-subnet clusters. If the nodes within your failover cluster all sit within the same data center, then no problem. You don't really have to think about this. But when you have a stretched cluster that would address disaster recovery requirements, you have to think about this. Now, ideally, it should be on a separate location. And when you think about it, this is how it works. You have, two nodes for your production data center and one node for your DR data center. You might want to put your file share on another data center. It could be on Microsoft Azure, or it could be in Azure Blob Storage if you're running Windows Server 2016 for your failover cluster. But as far as I'm concerned, that's really not practical. And so I usually place the file share witness, or in this case the quorum type, in the same location as what I'm trying to protect. Because if that location goes offline, I've got bigger problems to deal with. Now that we've looked at some of the principles and the concepts behind availability groups, let's take a look at some of the common design patterns. And usually I ask 4 questions when I look at a design pattern. What is my quorum model? And the quorum model dictates how I implement my design, based, of course, on business requirements. What will be my replication mode? Am I going to be using synchronous or am I going to be using asynchronous? What's my network configuration? Am I going to be having nodes within the same data center, or am I going to be stretching my nodes to a DR data center as part of my DR strategy? And of course, a more important question to ask is, what will be my licensing mode? Very important if you need to talk to your chief financial officer or the folks from your finance department. Let's look at the first common design pattern, a 2 replica with standalone instances designed mainly for high availability purposes. Let's answer those 4 questions. What will be your quorum type? Well, you could use a node as an extra vote, but I'm not really a big fan of having an extra node just for a vote because it adds up in terms of operational costs. I'm going to patch that node. I'm going to monitor that node. I'm going to maintain that node. I'm going to staff my engineers to make sure that node is well taken care of. That's why I'd rather use a file share witness for this. Now, I don't really have any issues with networking configuration because my nodes are in the same data center, and I'm only addressing high availability for this particular design pattern. What about my licensing mode? If I license my primary replica and I have software assurance, I could get away, or not get away, but I could legally run my secondary replica and I'll be covered. Again, just asking those 4 questions. The second design pattern now introduces DR. I now have 3 standalone instances where 2 of my nodes in my failover cluster or 2 of my replicas are in my production data center, and I've got 1 instance in my DR data center. Let's ask those 4 questions again. Now, in this case, you might be thinking, I've got 3 nodes. Do I need an extra vote for my quorum? Well, you have to think about it from the point of view of the business requirement. In this case, we want HA, or high availability. And again, I'm only going to be using file share in this case as my extra vote. Now, I can have 3 votes out of 4 within the same data center, which means I can have majority of votes, which can keep my availability group online in case the secondary replica in my production data center goes offline. What about networking in this case? Well, I have to consider talking to my network team about stretching this cluster, because now I have to deal with multiple virtual IP addresses for my availability group listener name. I also need to know whether or not I can provision additional virtual IP addresses on the network subnet where my DR node is. What about licensing? Well, in this case, because I'm only allowed to run one extra SQL Server instance free for every license, if I have software assurance, I will have to pay for my DR license, even though I'm only using it for DR. In terms of replication mode, between the primary and the secondary replica in my production data center, I can do synchronous replication. But when I have to deal with my DR replica, I would have to configure that with asynchronous replication. The distance between my production data center and my DR data center does not have to impact the performance of client applications connecting to my primary replica. When it comes to quorum configuration, it varies depending on the version of the Windows Server failover clustering that you're using. If you're using Windows Server 2008 or Windows Server 2012, the first release, not R2, you would have to remove the vote from that DR node. You certainly don't want the DR node to affect the availability of your replica in the production data center. When you're dealing with Windows Server 2012 R2 for your failover cluster, you would have to configure lower quorum priority node ID property to be that DR node. Now, if you're using Windows Server 2016, you can configure site awareness. Let's look at a different topology where you have a 2 replica. In this case, one replica is a failover clustered instance, and the other replica is a standalone instance. This covers both high availability and disaster recovery. Now, you could choose any type of quorum for this, but just a quick note that whenever you introduce a failover clustered instance as a replica on your availability group, you lose the ability to do automatic failover on the availability group level. On the instance level, you're still protected because the failover clustered instance takes care of the automatic failover. Let's take a look at the quorum type in this case. I can use a disk witness as an extra vote. Why? Because I'm using a failover clustered instance and I already have a shared disk that I can work with. I might as well make the most out of it. But you can still use a node or a file share. That's totally up to you. But I like the idea of maximizing the available resources that I already have. What about the quorum configuration when you're talking about that extra vote? Again, similar to the previous design pattern, if it's a Windows Server 2008 or Windows Server 2012, you have to configure the secondary replica on a DR node to not have a vote. If it's Windows Server 2012 R2, configure the lower quorum priority node ID property to be that node in your DR data center. If it's a Windows Server 2016 failover cluster, you can configure site awareness. And again, similar to when you're stretching your failover cluster to a DR node, you could configure asynchronous replication on the DR node for your availability group. You don't have to think about that from within the production data center because you only have a single replica. Now, in terms of licensing, you would need 2 licenses with software assurance. You need one for the primary replica, and of course, the primary replica has 2 nodes. The first license with the software assurance would cover the first node on the failover cluster instance and the second node. Let's look at a more complex combination of the previous design pattern, where you have 3 replicas, where one is a failover clustered instance and the rest are all standalone instances. You might have observed that there is somehow a pattern that's common across all of the design patterns that we've looked at. Let's say in this case, you want to use a shared disk as a witness type since you already have a shared storage subsystem for your failover clustered instance. Up to you whether you want to use a node or a file share. Again, that's the decision that you have to make. But again, I would prefer just maximizing any resource that I already have. Looking at the quorum configuration, I can configure the secondary replicas on those additional data centers with no vote if I'm dealing with Windows Server 2008 or Windows Server 2012. And if it's a Windows Server 2012 R2, I can configure lower quorum priority node ID to be those nodes in the additional data centers. Similarly, if I'm using Windows Server 2016, I can use site awareness. In terms of licensing, you have 4 nodes. I would need 2 licenses with software assurance to cover all 4 nodes. In terms of replication mode, I would configure asynchronous replication for all of them, mainly because they are on a different data center, and the distance between your production data center and the other data centers might be too long for the latency that would impact the performance on the primary replica. Another common design pattern is to have a 2-node failover clustered instance as a primary replica and another 2-node failover clustered instance as a secondary replica. This covers both high availability and disaster recovery. Asking those same 4 questions, you could use a disk witness, although in this case it would be a bit of a challenge to use a disk witness because you can't necessarily replicate the entire disk on the secondary site, which is your DR site. In terms of licensing, well, in this case, because you have 4 nodes in your Windows Server failover cluster, and all of them would have an installation in your SQL Server binaries, then you would have 2 licenses covered by software assurance to allow you to run the standby node for each failover clustered instance. In terms of the quorum configuration, if it's a Windows Server 2008 or 2012, you can configure those 2 nodes in the DR data center without any vote. Or if it's a Windows Server 2012 R2, you would configure lower quorum priority node ID to be those 2 nodes in the DR data center. If it's 2016, you can configure site awareness. Looking at the different design patterns, you may have seen some of the common patterns as well, and how you could address the design by asking those 4 questions. In summary, we've covered how Windows Server failover clustering works. We've covered how availability groups work, how the quorum affects the availability of the failover cluster, which in turn affects the availability of the availability group, and the different design patterns that you can pick and choose from to use for your own design. Of course, taking into consideration the business requirements, as well as making sure that you're minimizing the cost, especially in terms of licensing. Design according to business requirements, not because availability groups are cool and fancy and they're new. Make sure that you are designing your availability group topologies based on the business requirements. And of course, if you want to make your finance folks happy, minimize your licensing cost. I'm actually doing an online training class. It's a 3-day online training class specifically on this topic. It's the Senior DBA's Field Guide on SQL Server AlwaysOn Availability Groups. If you want to learn more about the training course, log on to that site. It will give you additional information about availability groups from start to finish, from simple design to more complex designs, to implementing other features alongside with it, like readable secondaries or read-only routing or load balancing of readable secondaries that were introduced in SQL Server 2016.